Study of Yellowstone's supervolcano is fueling new debate about where and when the volcano will erupt. Yellowstone National Park is home to some of the most iconic geothermal features in the United States. Beneath its colorful hot springs and spouting geysers lies a volcanic system that has intrigued geologists for decades. The latest findings shed light on how molten material could one day rise to the surface of this ancient hotspot. New instruments reveal 4 distinct magma bodies beneath Yellowstone, but only the northeastern one appears poised for future activity, according to Ninfa Bennington of the U.S. Geological Survey. Researchers have long documented 3 major eruptions at Yellowstone over the past 2 million years. Those events left behind giant calderas, which are vast volcanic depressions that form when large volumes of magma empty out and cause the ground to collapse. Such catastrophic eruptions are rare, so scientists are analyzing the residual heat and rock structure to understand how the system evolved. Each caldera tells a different story, providing clues about what lies beneath. Specialists use magnetotelluric instruments to detect electrical signals that reveal molten rock beneath the surface. These devices measure conductivity, allowing scientists to map magma zones without drilling. This approach suggests areas underground where molten rock might be accumulating. We found that rhyolite melt is stored in a discrete region beneath the caldera, wrote Bennington, the study's lead author. Of the magma bodies identified, only one, located in the northeastern sector of Yellowstone, is thought to retain enough heat to remain partially molten over the long term. The finding adds to a long-held idea that some areas could erupt in the future. We suggest that the location of future rhyolite volcanism has shifted to the northeastern Yellowstone caldera, Bennington said. This suggests a new potential center of volcanic activity at Yellowstone. Yellowstone is not the only place on Earth with a very large magma system. In Indonesia, the Toba supervolcano erupted about 74,000 years ago, causing significant global impacts. Scientists compare Yellowstone to Toba and other large volcanic areas to see how deeply buried magma behaves over time. Each site adds a piece to the larger puzzle of predicting when and how these forces will emerge. Predicting volcanic eruptions is a complex challenge. Experts watch seismic vibrations, changes in the soil and chemical signals to catch early warnings of magma movement. Groups like the Yellowstone Volcano Observatory share up-to-date information to help keep the public informed. They typically see low-level unrest, which doesn't indicate an immediate threat. Rumors of sudden natural disasters sometimes circulate. Geologists stress that supervolcano-scale eruptions require special conditions that rarely occur. Communities around Yellowstone benefit from ongoing research that tracks small shifts in the system. This research helps reduce uncertainty and shows that big events happen on a geological timeline, not human ones. Continued advances in imaging technology and field observations are refining our understanding of underground processes. By mapping details more precisely, researchers can spot variations in temperature and pressure that might signal larger changes. Experts stress that no single method provides a perfect forecast. Instead, some tools provide a more complete picture, improving the way we interpret the rumbling beneath our feet.